Thank you all very much for attending. I started doing systems administration on a VAX system running BSD4, so it's been a while. I haven't attended a USENIX conference in many years. I'm very excited to be back. The number of diverse people here and the things you're talking about and the things you're doing is just phenomenal. My name is David Kovar. I did incident response, cybersecurity consulting, program development, things like that for a Big Four consulting firm for the last 3 years. I took a year off to get a master's degree, which I'm finishing up now in international affairs. International affairs really does apply to pretty much everything that we're doing in cybersecurity. If you have any interest in that at all, come find me. This is a bunch of terminology around UAVs. The most important part of that terminology is the very first line where it says UAS. A UAV is the vehicle component of a UAS, which is an unmanned aerial system. From the start of these things, they understood it was a complex system. There's a system on the vehicle, and then that system on the vehicle connects to a much larger system. And that's where we get into the Internet of Things. I asked a question in the keynote. I will bookend my presentation with it as well. The solution to most cybersecurity problems in the Internet of Things, in SCADA systems, and medical devices, and UAVs is security engineering. Not software engineering, but security engineering, where we are looking at not just a software development cycle aimed at mitigating against errors, but we also need to mitigate and address malice and actors that are trying to threaten us. We need to understand psychology, we need to understand foreign cultures, we need to understand law and regulation. So, security engineering. UAVs are pickup trucks. They're very sexy pickup trucks. They're really cool. You can fly them, you can do spins with them, you can run them, you can race them. They're a pickup truck. They are flying low-cost airframes with low-cost, inexpensive computers with a very low-cost, low-power, high-fidelity sensor designed to collect information. That information will depend on, the sensor and the information will depend on what your purpose is. The most common one is an optical sensor, and GoPro and DJI and all these guys are trying to put the most capable camera on these things and collect data from it. The data collection process is not innovative. We've been doing this with manned aircraft for many, 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 many years. We're doing it with Google Earth. We're doing it with satellites. All these other things are collecting similar data. But what UAVs have allowed us to do is take all of that in-house. And I mean literally in-house. What people are doing at scale, like looking at infrastructure or mapping cornfields or whatever, you can do out of your own house with a DJI Phantom right now. The value, though, is not in the aircraft. DJI is making a lot of money selling aircraft. However, the people that are really making money, the people who are really innovating, and where a lot of the risk is in the data processing and the analytics. The Internet of Things there are a lot of definitions for it. Basically, it's a loose collection of network devices, computational devices, sensors, that sometimes are in a single package, but they are connecting out to a larger environment. They're talking to each other, they're talking to vendors, they're talking to operators, they're talking to a variety of connected devices. UAVs, as I said earlier on, same sort of thing. It's got a network on board, it's got a bunch of sensors, computational equipment, memory, all that sort of stuff that's interacting with its environment and interacting with the larger virtual world. UAV cybersecurity has a lot in common with SCADA systems. It has a lot in common with hospital medical devices. It has a lot in common with IoT. It has a lot in common with connected vehicles. If you know anything about that, or if there are good lessons to be learned from those environments, they will apply in general to UAVs. However, UAVs pose some new and interesting risks that are unique to those environments, but they can also go back and inform those other environments, and that's part of what we're talking about. UAVs need to integrate with the enterprise. You don't just pick up a UAV and say, hey, we're going to go fly it, produce some data. So business integration, somebody says, we want to go figure out what's going on in this cornfield. Or we want to go monitor the construction of this new building to see how much scrap is coming out of it, how many materials are going into it, how many trucks are in and out, all that sort of stuff. So somebody sets up these requirements. Those requirements get pushed down to the UAV management team, and they say, okay, we need to figure out what aircraft we're going to fly to do this. We need to figure out what teams are going to do it, what sensors, things like that. They push that down to field ops. Field ops says, okay, we got all this equipment, we know the teams, we're going to out and go fly this stuff. And the very end of that, there's actually a UAV up there flying, collecting this data and giving it back out. At every single step of that integration chain, you've got risk and you've got potentials for mitigating that risk. One of the unique things about UAVs and IoT, if you've got a lot of IoT in your commercial environment, is that there's a physical barrier that now the UAVs are operating outside of. You're not inside your corporate headquarters. You're not inside your buildings. You are flying someplace else, and your network is getting pushed out there. Your operations are getting pushed out there. Your legal interactions are getting pushed outside of your normal physical boundaries. These pose risks that you need to address as well. As you go look at your UAV environment, as you're trying to figure out what your risks are, where your pressure points are, where you can start improving everything, you got to look at your entire workflow. And we'll get into understanding where your data is, but you also need to understand how all these pieces tie together, who you need to talk to, who you need to work with. So there's a mission planning. These are probably not technical people per se. These are people saying, hey, we need to understand what's going on this construction site. These are business users. And they're going to set up the criteria. That criteria will determine whether you got a fixed wing or a multi-rotor. It'll probably determine the type of sensor or the payload. If you are, for example, in the oil and gas industry, that payload may not be an optical sensor. It may be something detecting methane gas, for example. Or it may be something detecting arcing on a power line. That will also help dictate the operator, where you're going to be operating, and the time frame. You've put together this mission plan. Somebody needs to approve it, but not just one somebody. The business needs to approve it. Yeah, we want to spend the money to go do this thing. Site logistics of the power plant needs to approve it. Safety, oh yeah, we cannot operate in that hazardous environment. We don't have the ability to do so. Legal, yeah, we've got the permission to operate in that environment. We've checked with the FAA and done all that sort of stuff. Risk, you need to have somebody doing risk assessment in here. They need to approve this as well. And flight ops needs to be able to say, yeah, we can go off and do this. Gets pushed down to execution. You got logistics, flight crew. They need to check with weather. You could probably have a weather guy now inside your organization for managing this stuff. You've now pushed this all the way down. Now the data starts coming back up. You've got this raw data, imagery. Now you got to start doing data analytics on it. You got to validate it. You got to generate the products that are going to be used farther up the food chain. You got to do quality assurance on that. And then finally, you're delivering this product to whoever asked for it. You may be delivering imagery. You may be delivering change rates. You may be delivering all sorts of things depending on what the initial requirements were. You also want to capture lessons learned, and you got to bill for this stuff. My background is in incident response. It's in computer forensics. It's in digital investigations. I'm sharing some of this with you because I want to show you that if you are operating UAVs, or that if UAVs are operating in your environment, where there is data that may put your organization at risk. What data is in this system? Where is it at rest? Where is it in motion? Where is it vulnerable? But also, you need to think about threats. What are the threats that are potentially impacting you, and how are they going to impact your system? Where are your systems most vulnerable? This is a very simple schematic of what the systems are on your typical quad-rotor UAV. It's got a bunch of motors which are driven by ESCs. It's got on the right side, it's got a camera with a couple motors for driving it, pitch and yaw. And it's got a SD card there. It's got a NI interface board. It's got a flight controller that is talked to by the remote controller on the ground with the guy flying it. It's got a compass and a GPS which interact with the environment. It's got an onboard flight controller which is mostly running Linux. It actually has, in this case, it has a Wi-Fi connection for getting the data link back down. The operating systems of most UAVs, all the way up to $100,000, are predominantly Linux. So if you know how to analyze Linux systems, you got a good shot at doing your own analysis of these systems if necessary. It also means that if you're familiar with Linux systems, particularly embedded Linux systems, you have an idea of the risk that they can pose to you and how hard they are to update. There may not be any interface to update them, or if you do update them, you may break the entire system. There are forensic artifacts throughout the environment. There are physical artifacts on the drone itself, on the ground station, in the support and post-processing environment. There are a lot of digital artifacts, different operating systems. Your ground control station may be Android or maybe iOS. There are embedded Linux in here. There's media storage, there are EEPROMs, there's firmware, there's all these different physical artifacts which manifest themselves also as digital artifacts. And then there are other systems for mission planning, maintenance logs, purchase records, and things like that, social media and fingerprints, which, if you're doing analysis, come into play. UAV data flows. This is just the UAV operating out in the field. The UAV has a base system and some communication links. It is getting information from the environment via that communication link. It's getting information from the ground via that communication link. It's got sensors which are collecting data from that environment. It's got avionics which are not only collecting data from the environment, but it's saying, oh, I've got 20 knots of wind now on my nose. I now need to increase the rotors to adjust my ability to hold station. And that's part of the autonomous control. The ground control station has got some operators which are talking to it. So there are a lot of different ways you could affect just this part of the system. You could spoof the GPS signal, which has been done. So if anybody believes it doesn't, let me know. I'll show you the research. I would not suggest doing it yourself. People get really pissed off. It can spoof GPS, and so this system now becomes compromised by somebody spoofing it. You can hack into the communication links and take control of it or pull data out of those. You can, by getting into that base system and disconnecting the control system from the ground, now give that UAV autonomous control and have it go off and do something that you've pre-programmed to do, which may not be what the operator wants it to do. Expanding outward from there, that UAV is now operating with the larger world. Starting in the upper left, we got the GPS signals, which we talked about. There's telemetry from the ground control station, which is what I'm using to operate that UAV, that's flowing back to the corporate headquarters. That may be telemetry, it may be real-time sensor data, it's a variety of different things. That's coming off the data link from the UAV to the ground control station and out to corporate. There's a payload operator who's probably got a set of joysticks who's controlling what that payload is doing, where it's looking, what it's collecting, things like that. There's a pilot in command, the PIC, that's got another flight controller who's talking with the aircraft to actually fly it. And then most likely, particularly where things are going now, this may be streaming data up to the cloud directly via LTE, via some other mechanism. So it's not even going back down to corporate, it's actually going up to the cloud, and then corporate is pulling that data out of the cloud either in real time or later. So if that's how all those systems interact and operate, what are some of the example risks that these things pose? So I talked about the ground control station. For most consumers and sort of low-end commercial operators, the ground control station is a mobile device. It's a tablet, it's an iPhone, it's something like that. The apps that are developed for doing all the work with UAVs are oftentimes incredibly insecure. This is data from the DJI Go app, and so there's a path to the plist. It had my full email and my password in the clear. So if you got my phone, you now had access to my DJI account, which had my purchase records, which had my credit card, which had where it was delivered to, all that sort of stuff. This is an older version. They've fixed some of these problems, but as usual, they've introduced some new problems into it. It's also got information about how I was flying it. So in this case, I was flying with a ground control station, and I wasn't doing FPV. there's an enormous amount of data above and beyond that. So just take my word for it. One of the other things it does is it records every time I connected that ground control station to my DJI, in this case Phantom 2. Using that data, just from that iOS app, not from the UAV, I can now plot every single place where I launch from. So let's say you're out doing surveys of your agricultural clients. If they can't get into the cloud, if the person trying to get the information about what you're doing can't get in the cloud, but they can go clone your phone or you drop your phone or whatever, they now have a record of every place you were. They can now say who your clients were and start getting a sense of what your business operations are and what your interests are. They can plot them. Also, there's data in there, other data which I'll get to. You can intercept the data in real time. Parrot, DJI Phantom 2s, a lot of the other sort of lower ends were using Wi-Fi. There was an access point on the ground control station. The UAV connected to the access point. Everybody here knows, okay, we can go de-auth, we can get into it. There are ways we can get into this data stream. So what you're seeing here is the commands that between the UAV and the ground control station telling the UAV what to do, but you also see the UAV reporting where it was launched from and where it is now. You can plot all of that, and I'll get to an example of that. I underlined something here at the bottom. I'm now looking at this data stream. This data stream is also what you're using for uploading information potentially either to corporate or to some sort of part of the cloud. How did you authenticate yourself to those environments? It's here. Could it be captured, replayed? Is it in the clear? All that sort of stuff. You've got to pay attention to it. UAVs can be hijacked. Parrot was the first one to be done. People figured out how to do it with the DJI Phantom 2s. It's relatively easy with the Wi-Fi. You basically de-auth somebody else. You pick up the authentication. You now have control of it. You can do whatever you want. You can use it maliciously. You can steal the UAV. You can steal the data, et cetera. As people are moving away from Wi-Fi for communications and for command and control, they're using 915 megahertz with something called Mavlink. That has been demonstrated to be vulnerable in a relatively easy manner. So you can now get into that command and control and data stream, take control of that environment. Okay, so we thought we could solve that particular problem. What we're really operating these things with is a radio controller, which has been around for eons. People have been flying remote control aircraft forever with these things. Great, these are very simple, they're very secure, we're good to go. No, somebody's figured out how to do a de-auth, auth attack on those, and you can now physically take control and shut the other guy out of his own environment, and again, do whatever you want with that UAV. This includes not just the $300 toy you buy for your kids. It does not just include DJI Phantoms. This includes the same controller that's used for $100,000 UAVs. So if you want to actually steal more than data, if you actually want a physical UAV, go out, figure out where people are flying, de-auth, auth, fly it away, you're good to go. There's another sort of insidious attack that you could do with this thing, and I'll get to in a little bit, but think about what happens if I steal your UAV, modify it, and then leave it where you can find it. The sensor metadata also has value to you, but also to the attacker. So this is from a DJI Phantom 3. It's just the EXIF data from an image. It shows what took it, when it was taken, how far above ground it was, and most importantly, where it was. So if you're up, so somebody can't get a hold of your iPhone, they can't get a hold of your UAV, but you're uploading this imagery someplace without stripping out the EXIF data, they can now plot all of your data from the EXIF about where you were, when you were there, and things like that. On the iPhone, on the Android, and on the UAV, there are log files, and there's some very good reasons for having log files. You want to do crash analysis. You want to say, why is this motor fluttering? Things like that. So the developers log everything. There's an enormous amount of data in there. And people now have put together websites, and this one's called Healthy Drones, where you can upload those log files, and now you can put together this map of where exactly you flew, with thumbnails. What aircraft flew it, when it was flown, who was flown it. Does anybody know what the terms of service are for Healthy Drones? What your relationship with them is? most of the people I've talked to that actually use it don't pay attention to that. Which gets us into this. My background, as I said, is in incident response. I'm usually concerned about people attacking my clients or attacking me. We're giving this information away to people who have an interest in using it that may be contrary to our own. This is drone deploy. This is the terms of service for drone deploy. Drone deploy is one of the most common iOS and Android apps combined with a cloud service where you can do mission planning. It will actually fly your UAV. You say, okay, this mission's good, hit go, it goes off and flies it, it lands, it uploads all of that data to their cloud, and then it takes those individual images, stitches them together, generates a 3D, what we call a DEM, digital elevation model, and makes it available to you. This term of service says they can use it for whatever they want also. So all your metadata, where you were, what you were doing, what aircraft you're using, they can use. But also all that imagery. So you just flew somebody else's, and I'm going to pick on China a little bit. China, I've actually been to China multiple occasions. I've done incident response with people in China. I think that they are a phenomenal partner, and I think that risks can come from pretty much any nation state and non-nation state actors. I'm going to use China as an example. It's not meant to pick on one particular country. However, or that said, we are now, through these cloud services, siphoning up a lot of information which documents a lot of what's going on in our country and making it available. And I'll cover this in a little more detail in a moment. DJI, similarly, has in their terms of service that in certain cases, flight telemetry data and operational records could be uploaded and maintained on a DJI-designated server under certain circumstances. Where are DJI servers located? They're in China. It's a Chinese company. The next part, in a different document, it says, when you choose to self-authorize or unlock flight operations on DJI hardware, and what they're doing, and they've got a no-fly zone built into their system, you can unlock that, which will allow you to fly into places that are sensitive, per the government or other reasons. When you unlock that, you are raising your hand and saying, I am going to go fly into an area that might be of interest to somebody. It may be a nuclear reactor, it may be near an airport, it may be power lines, it may be something, but I'm going to go fly there. So if you run a sim, for example, and you're looking for alerts, somebody who built a sim around this particular function now just got an alert saying this guy's going to go fly in this interesting area, let's pay attention to it. And they can go look at your data. And it'll upload automatically from their UAV. Which led to an interesting response from the Department of Interior. I had to file a FOIA to get the full details, and if you've ever pissed off the US government and filed a FOIA about what you did and you see your name in the response, it's a little bit intimidating. So I don't recommend going off and doing it unless you're prepared for that. The Office of Aviation Management for the entire Department of Interior wrote what's up on the screen, and I'll make the presentation available to everybody. But what they essentially said is that if you do not know exactly what your UAV is uploading and where it's uploading and when it's uploading, you should not be using it for sensitive projects. The upshot of all this is that the Department of Interior said you will not buy DJI products if you're using it for DOI purposes. Entire Department of Interior for the entire nation cannot buy DJI products. And if that's not news, I'm reading the wrong news articles. They went with 3DR, and there's some problems with that. There's a link here to my reporting on it. You can welcome to go take a look at that. And if you're really bored, I'll share the FOIA results. So what we're leading up to is this. We're not flying over empty fields. Well, some people, as they're learning, are flying over empty fields. But as we get more mature, as we get more comfortable, we're flying these things with a purpose. We want to go collect data about things that are of interest to us as individuals, corporations, or federal agencies. We're looking at critical infrastructure. We're looking at test crops. We're looking at new construction. We're looking at infrastructure impacted by disaster. We're looking at test tracks for like Ford or Caterpillar or things like that. We're not imaging things that don't have value to us. We are self-identifying valuable intellectual property. Again, we're raising our hand and saying, we're about to go image something that somebody else might be of interest to, be of interest to other people. Pay attention if you're interested. We are documenting assets of value. We're documenting their change or their value add. We're documenting their decrease or value decrease. This building got impacted by disaster. How badly was it impacted? These crops are growing faster than the crops over there. That's value add. The mission plans. So early on in that life cycle that you've got, those mission plans are sharing our intent and our interest in certain areas. So, and now I'm getting a little bit out in the science fiction realm, but if somebody said, okay, we want to go fly over what's now an empty field and we want to have resolution down to 1 centimeter, that tells me, as somebody who does geospatial analysis, they want to go build something there because you need that resolution for doing survey. And it's out near a whole bunch of water. Maybe a data facility, I don't know. But we're starting to share that sort of information. The flight logs that I showed earlier contain useful information. The UAV management data shares useful information. All this stuff gets aggregated to put together a really good picture of what we're doing and why we're doing it. Through this exposing what we're doing, we are posing risk to our own organizations. Hey, I just went off and imaged these crops. I just went off and flew over this test track as we were monitoring our new vehicle. I just flew over these power lines to see how old they are or what condition they're in. But as different people within that sector, within the power transmission lines, or within the automobile industry, or the ag industry, all do the same sort of activity, we are in aggregate building up a very comprehensive picture of that particular sector. We are also, over time, building up a very comprehensive, far better than Google Earth set of imagery about the current state of the entire environment. Where now a lot of this stuff is down to 1 3-centimeter resolution, and if we're flying these things regularly, it's much more current than Google Earth. If somebody can figure out how to aggregate all this data, they're going to have a very comprehensive understanding of not just a particular organization or a particular sector or a particular part of the infrastructure, but of a much larger part of our environment. All right, so there's risk. What do we do about taking care of that? These are from a group called BitTag. They put together the Internet of Things, security and privacy recommendations. There's a link to this at the bottom of the presentation. As I said, I'll share it. These are all things that we already know, but they bear repeating. We lack supply chain experience, or the supply chain does not have an interest in helping us secure the parts that are coming in to build the larger systems. There's a lack of incentives to build security into these systems. We want the lowest possible cost UAV, or we want a billing system or a planning system that's out now, not 3 months from now. We've got to figure out ways of building those incentives in so we start getting more secure parts of the ecosystem. Even if we're putting out the right pieces of the environment, getting them upgraded in the field is very difficult. And this is where I tie back into SCADA, or hospital devices. When I was doing incident response, we kept finding that the initial point of attack was some heart monitor out on the floor of the hospital. And it's like, okay, we got to take this thing offline. You can't do that. It's in operation, and plus we got 30 more of them. What are we going to do? All right, we need to upgrade it. No, if you upgrade it, then it breaks, and we can't do that. What do we do? This is the recent DDoS attacks that hit Krebs and a whole bunch of other places were done by, I think it was 50,000 poorly secured IP cameras. Okay, so that vendor got blasted. I just saw recent reporting that says there are about 100,000 Sony IP cameras that have a similar vulnerability that the malware is not aware of yet, but they could easily tweak. How do we upgrade these things in the field? The answer for some of this stuff is you just toss it out and you go buy another one. Who's to say the next one doesn't have a different vulnerability that's just waiting to be exploited? A lot of these devices are constrained through power. As I said, inexpensive, low-cost components. If they're going for just enough CPU power to be able to do what they need to do, there's not enough horsepower there to also handle encryption. You've got to say, okay, we're going to spend more to be able to get that capability. There's no user interfaces for getting down to some of this sort of stuff. That UAV, I've got to trust DJI's app to go upgrade the firmware on the battery, on the flight controller, and the GPS. But there are other components in there that that UI doesn't touch, and there's no way for me to upgrade, and I suspect no way for them to upgrade. And then there's the cases where devices come out with malware during the manufacturing process, including BIOS for Windows PCs. So we have to go figure out ways of addressing all these things. For UAVs, if you're flying more than one, you've got a fleet. So start thinking about fleet management. It's not my area of expertise, so this is just sort of a placeholder saying if you're doing that, go look into fleet management. But it also applies to things, if you're doing SCADA systems, if you're doing medical devices, you are managing a fleet. It doesn't happen to be a mobile fleet, but it's still a fleet of devices, and there are things to learn from the fleet management people. One of the unique challenges for UAVs is airspace management. You own a bunch of land out there, and you got your corporate environment sitting out there. You're flying UAVs around it, and somebody else flies over your environment. Are they flying illegally? Yeah, I see it has nodding yes. The answer is no. The answer is, and there's some debate about exactly where the FAA controls airspace and where you don't, but it's somewhere between 1 inch off the ground and the sort of roof line. But if you say, okay, no, UAVs can't fly over it, then I'm going to go grab my helicopter, put even better sensors on the helicopter, and fly over and do the same thing. You do not control the airspace above your environment. And the FAA is still struggling with who does and who doesn't, and that's going to be going on for a while. If there are multiple UAVs operating in your environment, you've got a couple 100,000 acres of wheat out in the middle of Wyoming, can you detect all the UAVs operating in that environment, and can you differentiate between yours and somebody else's? Don't know. Can you monitor UAV to detect changes in flight? This one comes out of the military, but it's still worth thinking about in the consumer space and the commercial space. The military is concerned that they fly a Predator out there for a particular mission. Somebody else hacks into that Predator and either uses that for their own purposes or uses it to send back a compromise into your environment. That's not a good thing. And finally, okay, you can do all this. You can figure out that, hey, we got to control the airspace. We can detect UAVs. We can detect changes in UAVs. Have you built these UAVs or IoT or whatever it is that we're trying to address here into your incident response program? And I will tell you with some degree of not certainty, I've seen a lot of environments where medical environments, SCADA environments and things like that, where they had not built into their incident response program how to respond to some of these devices or even monitoring around some of these devices. We would find out that these devices were compromised after something farther down the road got compromised and we had to go back and find the initial point of compromise. You've got to start monitoring everything and early. So the factors that affect UAVs, the risk factors. There's physical exposure. The communication systems are potentially vulnerable. They've got storage media on them. They've got sensor systems on them. Do you know how they're going to handle faults? If they lose communication, what are they going to do? If they suffer a power failure, what are they going to do? If they suffer a motor failure, what are they going to do? And that's either through accident or through malice. What are your mission plans systems doing? Are they leaking information? Can they be compromised? Ditto for your maintenance systems. Do you think you're upgrading your firmware when you're not really doing so? UAVs do not operate within the confines of your corporate environment. You have to take into account the geography where they're operating, the weather they're operating in, local, state, national law, regulation, and policy, mission requirements, mission plans. These are all things that as you're doing risk analysis for UAVs, you need to factor in, which leads to a fairly simplistic UAV risk assessment model. You can modify this to your heart's content, but the general idea is that you've got two different flows. You've got to evaluate the risks associated with the mission and the risks associated with the UAV. On the mission side, you've got to take into account your goals. You've got to take into account the environment. You've got to think about the probability of whatever event is going to occur, factor that in. And then on the UAV side, you've got to do threat analysis. You know, why would somebody compromise this? I still have about 10 minutes? 9. We're good. Why would somebody compromise this? That's your threat analysis. You figure out your occurrence probability, and you put this into your risk assessment. And out of that risk assessment comes your typical CIA, integrity, confidence, and availability. You can do this, once you put this into place, it's very simple to do. And it helps you determine whether you're using the right systems, whether you're making the right decisions, whether you should fly or not fly. And this is, in putting this together, you can go back and answer a lot of other questions about why you are operating what you're operating with. So what should be done? This is, again, things that are familiar to all of us. From my perspective, it's about people, process, and technology in that order. You need to hire the right people. Those people need to have a security mindset. Even if they're working in marketing or they're working in purchasing, the purchasing people need to understand that, hey, we want to spend X dollars more on this product because this product has security built into it and this other one doesn't. Those are important. You need to be at least be working with the same vocabulary so you can have those discussions. Implement sound, reasonable security processes around your own intellectual property. There's an enormous amount of data out there on how to go about doing this. It's for a different conference or a different part of this conference. Invest in useful, well-supported technology. I cannot tell you the number of times that I've responded to an environment and they had $500,000 worth of hardware sitting there unused, and they hadn't sent people to conferences such as this because they spent the money in the wrong spot. Buy the right stuff. Get involved with regulation early. This is a quote from Mark Harris. There was a company called Otto which was developing self-driving trucks, and they were testing it in Utah. And Utah said, you have to follow these particular requirements. And Otto essentially said, eh. And they, according to them, and they're walking it back, they put a self-driving truck without a driver in the back seat on the road, highways in Utah and drove it for several hundred miles. And then they moved out of Nevada. But that test got them bought by Uber for $680 million. Well, not just that test, but that sort of, let's flaunt the regulation to get the innovation going. If you flaunt the regulation, either in the development of UAVs or the application of UAVs, then the regulations will not be mature enough to help protect you down the road when you need it. Securing unmanned, and I had aerial and I crossed it out. This is securing unmanned systems in general. Vehicles of all sorts. IoT to some extent. Design security in, collect the least amount of information, and the information you collect, secure it. Know where it is, know where it's moving, make sure it's encrypted, make sure you can keep track of it. Select vendors who share your vision. Conduct a security audit of your system as it's designed. Mission planning all the way through product delivery. And then once you implement it, conduct another audit and make sure that if you designed it this way, that what you implemented is the same. And if it's not, figure out where the differences are and whether you added more risk or you decreased your risk, and keep auditing it. Include your UAVs or your medical devices or your IoT in your threat modeling and in your incident response program, and train your staff on all the risk elements associated with this. As I said, marketing, purchasing, all that sort of stuff. These are some resources. NTIA has a UAV best practices on privacy, transparency, and accountability issues. That link is here. The BitTag link is here. And my blog on some of the things relating to UAV forensics and cybersecurity is also in here. The presentation will get mailed to USENIX as soon as I'm done. It's available. My email address is dkovar@gmail.com. I am happy to talk about any of this sort of stuff. If you have questions or feedback or anything about how I can make this more informative for either you or people like you, please let me know. I am very interested in figuring out how to make this more valuable to you. I don't care about myself really. I want to make sure that you're getting the best possible information you need for getting your jobs done. And that's it. I got 3 minutes. If anybody's got any questions, please feel free to ask. The microphones are up there. If you don't have questions that you want to announce publicly, please come find me. And seeing no questions, I think we're done.
Thank you.
Cool.